Welcome back. So in this video, we are using the Kirchhoff laws to solve for the current and voltage in this circuit. Alright. So looking at this circuit closely, you can see that the current direction is being assigned, and there is a node here for, let's call this current I. Upon reaching this side, it splits to have I1 and I2, which joins back here to pass through the 5 ohm resistor back to the source. Alright, so our 4 ohm resistor is in parallel to the 6 ohm resistor, and we have our 40 volts, which is in series with the 5 ohm resistor. Okay, so the question is saying we find the current flowing through the 6 ohm resistor. Alright, so before that, we have to find the total resistance in a circuit, which will help us find the total current, and which will later help us find the current flowing through the 6 ohm resistor. So let's begin. So the total resistance, we know this and that is in parallel, which will be in series with that. So our total resistance is equal to the 5 plus the resultant resistance for these two resistors. That is 4 times 6 over 4 plus 6. And upon computing this gives us 7.4 ohms. In our previous video, we talked about the Ohm's law, where we concluded that V is equal to IR. So having our V to be 40 and our R to be 7.5, we can find our I, which gives us 40 over 7.4. And then this gives us 5.405 ampere. Now, we have the total current I, that's 5.405 ampere. So this total current reaches the side and is split based on the resistor values. But we can do this just by predicting. So we go in for one formula called the current divider rule. Right. So the current divider rule will help us find the current I2, which is the current that passes through the 6 ohm resistor. So this is how the current divider rule plays out. So I2 is equal to, so with the current divider rule, we take the opposite resistor. So in this case, the opposite resistor to the 6 ohm resistor is 4. So 4 over the sum of the resistors in parallel. So 4 plus 6 times the total current. That's 5.405 ampere. And upon computing this, we have our I2 to be 2.162 ampere. So this is our I2. So from this diagram, we can write our KCL as I is equal to I1 plus I2. Now we know I2, which means we can find I, right? And also the second question is telling us to find the voltage drop. In our previous video, we talked about the Ohm's law as we concluded that V is equal to IR. So with the voltage drop across the 6 ohm resistor, we take the current across that's I2 times the resistor in play, that's 6. So we have 2.162 times 6, and this gives us 12.972 volts. So this is the voltage drop across the 6 ohm resistor. All right, I believe this calculation is very simple. Follow through. In any doubt or confusion, leave your questions in the comment section and it will be attended to. All right, take a look at this video again, share with friends,